Welcome back to the unit on transformations. In today's lesson, you will learn about writing equations for lines which do not pass through the origin. You will be able to write an equation to represent a line that doesn't pass through the origin, and you'll be able to determine whether a point is on this line. So on the left-hand side, we see an equation we wrote in a previous lesson where we had this triangle ABC with a slope of 2 because the vertical increase was 2 here and the horizontal increase was 1. So we had y equals 2x. And now we have that same triangle in the right-hand graph, ABC, moved up one box on the graph. And so our points now are 1, 3, 2, 5, and 3, 7, as opposed to 1, 2, 2, 4, and 3, 6. So we can see that the x value is the same on both graphs, but the y value on the right-hand graph here is 1 more than on the left graph. And that's because the whole line has been moved up one notch on the graph to here. It comes through here instead of going through the origin. And this point here, 0, 1, is called the y-intercept. It's where the line meets the y-axis. And so the pattern we see is that y is equal to 2x still, but with 1 more added to it. And we can check that. We can say when y is, for example, 3, that's 2 times, I'm going to use a different color to make it stand out here. 2 times 1 plus 1. That is correct. 3 is equal to 2 plus 1. So our equation is y equals 2x plus 1. Let's look at another example. Here we're going to start with the y-intercept at 0, 1. That's your y-intercept. So 0 on the x-axis, 1 on the y-axis, with a slope of 3 over 1. So 3 is your vertical rise, and 1 is the horizontal change. So we go up 3, 1, 2, 3, and to the right 1. We can make a few more points. 1, 2, 3, to the right 1, 1, 2, 3, to the right 1. And now we can join these up. And there's our line. And so our equation is that it's going up by 3 each time. So y equals 3x. That's how much it's changing. But if we put plus something, let's put the numbers into the table here. X is 1, 1, 2, and 3. So when x is 1, y is 4. When x is 2, y is 7. When x is 3, y is 10. And so what we have here each time is that we multiply x by 3 still. 3 times 1 is 3, plus 1 is 4. Let's look at the second one. Y is 3 times 2 is 6, plus 1 is 7. And in the third row here, 3 times 3 plus 1 is 10. So our equation is y is equal to 3x plus 1. And that 1 matches the y-intercept here. This is your y-intercept. So when writing these equations, y equals the slope multiplied by x plus the y-intercept. So let's look at one more example here. We're going to start at 0, 3, and with a slope of 1 over 2. So we're going to vertically increase 1, horizontally, increase 2. Up 1 to 2. Sorry, I'm really messing up here. But okay, got it right now. Going up 1 over 2, up 1 over 2, up 1 over 2, and so on. So there's my line. And my equation is going to be y equals the slope times x plus the y-intercept. So y equals, I'm told the slope is a half, so a half x plus the y-intercept is 3. Now could this point 30, 45 be on this line? So I'm going to go y equals a half x plus 3, substitute in 30 for x and 45 for y, and will it be correct? If it's correct, it means the point is on the line. So 45, is that equal to a half times 30 plus 3? Is 45, is it equal to a half of 30 is 15 plus 3? Oh no, this does not look like it's equal. 45 is not equal to 18, which means the point cannot be on this line. I'm going to write no. So let's look at another example. Y is equal to 2 over 3x plus 5. So 2 over 3 represents the slope and 5 represents the y-intercept, which is the point we'll start from. So go up to here, there's my y-intercept, and then the slope is 2 over 3, so rise 2, horizontally run 3, vertical rise 2, horizontal run 3. There's the line. And could the point 30, 45 be on this line? Y equals 2 over 3x plus 5. So I'm going to substitute 30 for x and 45 for y. 45 equals 2 over 3 times 30. Could this be true? Is 45, is it equal to 2 over 3 times 30? So 2 times 30 is 60. 60 divided by 3 is 20. So is 45 equal to 20 plus 5? Nope, 45 is not equal to 25. So this point 30, 45 is not on the line. No. So here I want to write an equation for a line for the graph on the left-hand side. And I know that I need to write it in the form y equals slope times x plus the y-intercept. And I can get the slope from the points I'm given. I'm given 5, 3 and 7, 7. And also I can see in between them, I've got these other points that are not labelled. So I can see that the slope, I'm going to just start at 5, 3, goes up 2 and to the right 1, up 2 to the right 1, same all the ways along. So the slope is 2 over 1. And you can write that as just 2 if you want. So 2 over 1x plus the y-intercept. But I can't read the y-intercept from the graph because it's cut off. So I redrew it on the right-hand side. And I drew similar triangles all the ways along the line until I found the y-intercept. And the y-intercept is here at 0, -7. That's my y-intercept. So to use that now in my equation, y equals 2x plus negative 7. Or I can write it to tidy it up. Y equals 2x minus 7 is the equation for this line. So to summarize, I need to mark my points and calculate slope, and then I need the slope and the y-intercept, and write the equation in the form y is equal to the slope times x plus add on the y value of the y-intercept. So today you learn to write an equation to represent a line which does not pass through the origin, and you saw how to substitute x and y values from a point into the equation to see if that point could be on that line. And that's the end of today.